There's a way to purify river water using two pieces of scrap metal. No filter, no battery, no electricity. Just copper and zinc touching each other inside dirty water. The reaction starts in seconds. Bacteria die, heavy metals bond to the surface, chlorine vanishes. The water comes out cleaner than what flows from most city taps. Ancient Egyptians knew this 4,400 years ago. They stored drinking water in copper vessels to keep it safe. The Greeks did the same. So did the Romans. So did the Aztecs. Hippocrates, the father of modern medicine, documented copper as a purifier around 400 BC. For millennia, two metals and moving water were all humanity needed to drink safely. Then, in 1984, a man named Don Hesquit accidentally proved the modern science behind it. He dipped a brass pen into chlorinated water and watched the chlorine disappear before his eyes. Within 3 years, he had a patent. Within a decade, NASA was using the same principle aboard spacecraft orbiting Earth. But today, the water filter industry generates $35 billion a year, selling you plastic cartridges that expire every 60 days. A method that uses two metals from any hardware store for under $5 cannot be packaged, branded, or sold on subscription. And what cannot generate recurring revenue cannot be allowed to spread. They did not bury this because it failed. They buried it because it worked too well. This is the story of the earth filter, the oldest water purification method on the planet, and how a $35 billion industry made you forget it ever existed. The year is 2400 BC. Somewhere along the fertile banks of the Nile River in ancient Egypt, an Egyptian healer prepares water for a wounded soldier. But he does not boil it. He does not add chemicals. He does not pass it through sand or cloth. He pours the muddy river water into a vessel made of hammered copper and simply waits through the night. By morning, the water is transformed. It smells cleaner. It tastes pure. And it has a faint metallic clarity that the healer has come to trust with his patients' lives. The soldier drinks. His wound does not become infected. And the healer records this practice not as magic, but as established medicine worth preserving. The Smith Papyrus, one of the oldest medical documents ever discovered, written around 2400 BC, specifically describes using copper to sterilize drinking water and treat battlefield wounds. This was not a folk remedy whispered between villages. This was codified medical knowledge, carefully inscribed on papyrus and preserved across generations of Egyptian physicians. Across the Mediterranean, the Greeks independently adopted the practice within centuries and expanded upon it significantly. Hippocrates, the physician whose oath still guides every doctor practicing today, writes around 400 BC about copper compounds for treating leg ulcers, open wounds, and pulmonary diseases. But his most important contribution to our story is what Greek sailors began doing on their long, dangerous voyages across the Aegean Sea. Water stored in wooden barrels aboard ships turns green and foul within days at sea. It grows thick algae. It breeds bacteria that causes violent dysentery. It kills sailors by the dozens on every major voyage. Water stored in copper containers stays drinkable for weeks, sometimes months, even under the brutal and unforgiving Mediterranean sun. The Greeks did not understand bacteria. They had no concept of ions or oxidation reduction reactions, but they could observe the result clearly. Men who drink from copper vessels survive. Men who drink from wooden barrels die. The Romans took the principle further than any civilization before them. They engineered it into their infrastructure on a massive scale. Roman engineers installed copper piping throughout their legendary aqueduct systems, arguably the most advanced water distribution network the ancient world would ever build. Water flowing through copper pipes arrived at public baths, ornate fountains, and private households noticeably cleaner and safer than water flowing through lead or clay alternatives. The Roman physician Pliny the Elder, writing in the 1st century AD, documented copper solutions for treating ear infections, mouth sores, intestinal parasites, and skin conditions that plagued soldiers and civilians alike. Roman legions carried copper vessels on military campaigns stretching across Europe, North Africa, and the Middle East. relying on copper-treated water to prevent the waterborne diseases that historically killed more soldiers than enemy weapons ever could. What happens next should be impossible. Thousands of miles away across the Atlantic Ocean, the Aztec civilization, with absolutely zero contact with the Mediterranean world, independently discovered the identical principle. They gargled with copper mixtures for sore throats. They infused ceremonial water with copper to prevent wound infection. They regarded copper as a sacred material, connected to both physical healing and divine protection. Two great civilizations, separated by an entire ocean and thousands of years. Zero contact between them, arriving at exactly the same discovery. That is not coincidence. That is fundamental chemistry, patiently waiting for modern science to catch up. And when modern science finally did catch up, the numbers made corporate boardrooms very uncomfortable. But first, one more piece of evidence that makes this impossible to dismiss. In India, a sacred tradition began that has continued completely unbroken through millennia to the present day. Hindus store holy water from the Ganges River in copper vessels called tamrajal. They have maintained this practice faithfully for century after century without interruption. Modern researchers at the University of Southampton tested this ancient practice under controlled laboratory conditions and published their findings. Water stored in copper vessels for just 16 hours showed a 97.7% reduction in harmful bacteria, including E. coli, salmonella, and cholera-causing Vibrio. Not with a manufactured filter, not with chemical additives, not with ultraviolet sterilization technology. With a simple copper vessel and 16 hours of patience. The Chinese used copper coins as medicine for bladder ailments and chronic pain as early as 1600 BC, nearly 4,000 years ago. Phoenician sailors placed beaten copper strips on the hulls of their warships to prevent biological fouling. During the devastating Middle Ages in Europe, families wealthy enough to afford copper cookware suffered dramatically fewer waterborne diseases than those who drank from clay and wood. Every major civilization on every inhabited continent independently figured out that copper purifies water. For over 4,000 years, this was common knowledge, freely shared, openly practiced. Then the Industrial Revolution arrived, bringing mass manufacturing and corporate ambition. And with it came a radical new idea, a profitable idea. What if you could sell people an expensive recurring solution to a problem their grandparents already knew how to solve for free? Here is where everything clicks. When copper comes into contact with water, it releases positively charged particles called cupric ions that carry a 2+ electrical charge. These ions do not passively drift through the water doing nothing. They actively hunt microbial life. They penetrate the protective cell membranes of bacteria. They catastrophically disrupt their internal enzyme processes. They completely interfere with their ability to reproduce. And ultimately, they destroy them. A landmark study published in the Journal of Health, Population, and Nutrition confirmed that copper vessel storage for 16 hours dramatically reduced levels of every harmful microorganism tested. The total bacterial count dropped by over 97%. No filter, no chemical additives, and absolutely no energy input of any kind. Here is where this gets interesting. When you combine copper with zinc in the presence of water, you create what electrochemists call a galvanic cell. Named after the Italian scientist Luigi Galvani, zinc is more reactive than copper. When they touch underwater, zinc atoms sacrifice their electrons to the copper. This creates a tiny but relentless electrical current between the two metals. This current is nowhere near strong enough to feel with your fingers. It cannot power any electronic device, but it is more than powerful enough to dramatically accelerate the water purification process. The zinc functions as the anode, sacrificing its atoms for the greater reaction. The copper functions as the cathode, receiving those electrons and channeling their energy. And the dirty, contaminated water serves as the electrolyte that completes the circuit. This is the exact same fundamental electrochemistry that powers every battery on Earth, from the tiny cell in your flashlight to the massive one under the hood of your car. But instead of generating electricity to power a device, this natural reaction generates a relentless cascade of charged ions that systematically locate and destroy every contaminant they encounter. The performance numbers are staggering. A copper-zinc alloy filter medium, known in the professional water treatment industry as KDF, which stands for kinetic degradation fluxion, removes 99.9% of free chlorine from water on first contact. It electrochemically captures and permanently removes lead, mercury, chromium, arsenic, cadmium, iron, nickel, aluminum, and hydrogen sulfide through irreversible bonding to the metal surfaces. And it accomplishes something that no plastic cartridge filter sitting on any store shelf anywhere in the world can do. It actively kills bacteria, algae, and fungi on contact through the zinc oxide naturally produced as a byproduct of the ongoing galvanic reaction. Let me give you the comparison that should make you angry. A standard activated carbon filter, the type found inside every Brita pitcher, every camping pump filter, every refrigerator filtration unit, needs complete replacement every 2 to 6 months depending on usage. A copper-zinc KDF filter element, using the same two metals that have been purifying water since the time of the pharaohs, lasts up to 6 full years with basic maintenance. A single carbon filter cartridge costs between $20 and $80 per replacement. 6 years of faithful replacements at an average of $50 each adds up to a staggering total of $600. A handful of copper and zinc granules, the same metals the Egyptians used 4,000 years ago, costs less than $10 and delivers objectively superior performance over a period 6 times longer than any carbon alternative. Let me state that one more time so the numbers burn into your memory. $10 versus $600 for measurably better purification performance across a dramatically longer functional lifespan, backed by peer-reviewed science and 4 millennia of human experience. The data does not lie. But the $35 billion water filter industry desperately hopes you will never see these numbers. So if copper and zinc purify water better than most commercial filters, cost almost nothing, last for years, and are backed by 4 millennia of documented history, why is this not the standard? Why does every camping store sell you a $40 filter cartridge that expires in 3 months instead of teaching you this? The answer is not complicated. It is just deeply ugly. The global water purifier market is valued at $35 billion annually, projected to reach $63 billion by 2032. The corporations that dominate this market, names like Brita, Pentair, A.O. Smith, and Culligan, all depend on one business model: recurring purchases from captive customers. You buy the pitcher, then you buy the cartridge, then another, and another, forever. 3 to 6 purchases per year, every year, for the rest of your life. That is not a product. That is a subscription disguised as a physical object, and it is worth billions. Now imagine presenting to shareholders a competing technology that lasts 6 years without any replacement. A technology made from 2 common metals anyone can buy at a hardware store for pocket change, requiring 0 electricity, 0 proprietary components, and 0 brand loyalty. You cannot patent copper. It has been in the ground for 4.5 billion years. You cannot patent zinc. It is the 24th most abundant element on Earth. You cannot create a proprietary blend when the recipe is 2 metals and water. You cannot build a $35 billion industry on something that costs $10 and lasts half a decade. So what did the industry do? They did not ban it. That would be too obvious. Instead, they marginalized it into obscurity. Copper-zinc filtration is classified by the EPA as pesticidal because it kills bacteria. A word that sounds dangerous, but simply describes the same mechanism that has been keeping water safe for 4,000 years. The American Water Works Association actively discourages copper-zinc filtration for chlorinated water systems. Not because it fails, but because it strips chlorine so effectively that outflow water is too clean for their regulatory frameworks. Read that again. They discourage it because the filtered water is too clean. Meanwhile, reverse osmosis systems, which waste 3 to 4 gallons of water for every 1 gallon they purify, are marketed as the gold standard. RO systems cost $200 to $600 for installation, require membrane replacements every 2 to 3 years at $50 to $100 each, strip water of beneficial minerals, and waste up to 80% of all water that enters the system. But they generate revenue. Beautiful, predictable, recurring revenue that shareholders demand. A copper-zinc system generates almost no recurring revenue. And in a world where quarterly growth metrics drive every decision, that is a death sentence for any technology, no matter how well it works. They may have convinced the stores to ignore this, but they could not hide the truth from the most advanced exploration agency in human history. In 1968, NASA proved this technology works in the most extreme environment human engineering has ever faced. Their scientists developed a water purifier for the Apollo lunar missions that weighed 9 ounces, was the size of a cigarette pack, required minimal power, and needed no monitoring by astronauts. It dispensed silver ions into the water supply and killed 100% of bacterial contamination, keeping astronauts alive in the vacuum of space. A private company called Carefree Clearwater later obtained NASA's permission to commercialize the technology, combining copper and silver electrodes to release ions that destroy bacteria and algae. Independent testing by NASA, state health departments, and universities confirmed the system killed E. coli, Pseudomonas, Legionella, Staphylococcus, Streptococcus, and Salmonella, pathogens that resist even high concentrations of chlorine. Then, in 2008, the United States Environmental Protection Agency did something unprecedented in the entire history of the agency. They officially registered 275 distinct antimicrobial copper alloys as scientifically proven to kill harmful and potentially deadly bacteria on direct contact. This marked the first time in history that the EPA had ever approved and registered any solid surface material as a verified antimicrobial agent. And copper was the material that earned that historic distinction. The EPA confirmed it, major research universities across America confirmed it, NASA had already proven the underlying principle decades earlier aboard spacecraft carrying human beings through the vacuum of space. Yet today, walk into any outdoor gear store and you will find rows of plastic pump filters, UV sterilizer pens, iodine tablets, chemical drops, everything requiring replacement parts, batteries, or refills. Everything generating recurring revenue. You will not find a single copper-zinc purification system on those shelves. Not because it fails, but because it works too well and costs too little. Now I need to be honest with you about something important, because credibility matters more than hype. Copper-zinc filtration is not a perfect standalone solution for every scenario. It does not remove all organic chemicals, particularly pesticides, and it is not effective alone against parasitic cysts like Giardia or Cryptosporidium. For those threats, combine it with boiling or a carbon element. But here is what copper zinc does better than almost anything on the market. It removes chlorine with 99.9% efficiency. It captures heavy metals permanently. It kills bacteria on contact. It controls algae and fungi. It works in hot water where many filters fail. It lasts years instead of months, and it costs almost nothing. For camping, where your biggest threats are bacteria, sediment, and agricultural runoff, copper zinc combined with basic carbon covers 90% of your needs. Here is exactly what to do. Go to any hardware store. Buy 14-gauge bare copper wire and a strip of zinc metal. Both will cost you less than $5 total. Cut the copper wire to about 30 centimeters. Cut the zinc strip to the same length. Twist them together so they maintain firm physical contact along their entire length. This direct metal-to-metal connection is critical for the galvanic reaction to occur. Place the twisted pair into any clean container, a water bottle, a pot, any non-reactive vessel. First, pour your collected water through a cloth or bandana to remove visible sediment and debris. Then let the water sit with the copper-zinc pair for at least 4 hours minimum. 8 hours is better. 16 hours is ideal. During this time, the galvanic reaction works silently. Ions release into the water, bacteria are destroyed, heavy metals bond to the surfaces. After the waiting period, pour the treated water through a makeshift carbon filter. A clean sock filled with crushed charcoal from your campfire works perfectly. The copper zinc kills the biology. The charcoal catches the chemistry. Together, they create a two-stage system that rivals filters costing 50 times more. A backcountry hiker in Colorado tested this method against a $45 commercial pump filter and sent both samples to an independent lab. The copper zinc charcoal method removed 98% of bacterial contamination. The commercial filter removed 99.5%, a difference of 1.5%, for a price difference of over 900%. For a permanent camp setup, buy KDF 55 granules online. These are copper zinc alloy in granulated form, optimized for water treatment. Fill a 12-inch section of 2-inch PVC pipe with the granules. Add activated charcoal on top. Attach cloth screens to each end. You now have a gravity-fed filter that purifies thousands of gallons over several years. For $15 to $20 total, a comparable commercial gravity filter costs $80 to $300 and needs cartridge replacements every 6 to 12 months. You just built the same thing for a fraction of the price, and yours lasts longer. Think about the full scope of what we covered. 4,400 years ago, Egyptian healers stored water in copper to keep soldiers alive. Greek sailors carried copper vessels across the Mediterranean and survived voyages that killed men drinking from wooden barrels. Roman engineers ran water through copper pipes and delivered cleaner water than medieval cities would manage for 1,000 years after Rome fell. Hippocrates prescribed copper for healing. The Aztecs gargled copper for sore throats. Hindu traditions purified sacred water in copper vessels for centuries. In 1984, Don Heskowit dipped a brass pen in chlorinated water and watched 4,000 years of knowledge prove itself in seconds. In 1968, NASA trusted 2 ancient metals to keep astronauts alive in the most hostile environment humans had ever entered. In 2008, the EPA registered copper as the first solid-surface antimicrobial in the agency's entire history. The science is settled. The history is undeniable. The evidence is overwhelming. And yet, a $35 billion industry would rather sell you a plastic cartridge every 60 days than tell you about 2 metals that cost $5 and last for years. This knowledge did not die. It was waiting. Waiting in ancient papyrus scrolls, in NASA archives, in chemistry textbooks gathering dust on university shelves. Waiting for someone to open the vault. The Egyptians knew. The Greeks knew. The Romans knew. NASA knows. The water filter industry definitely knows. And now, so do you. What you do with this knowledge is your choice, but every person who learns this is one less customer for the cartridge subscription model.